Digital Assets AG, a Switzerland-based firm that tokenizes financial instruments, launched its tokenized stocks on the Solana blockchain last week. But wait a second, what is Solana? Let's understand all about it. Hello and welcome back. I am your host Kushagra and you are listening to Satoshi Saturdays. What is Solana? Solana is a web-scale blockchain that provides fast, secure, scalable, decentralized apps and marketplaces. The system currently supports 50,000 transactions per second and 400 millisecond block times. The overarching goal of Solana software is to demonstrate that there is a possible set of software algorithms and use the combination to create a blockchain. So this would allow transaction throughput to scale proportionally with network bandwidth, satisfying all properties of a blockchain: scalability, security, and decentralization. Furthermore, the system is able to support an upper bound of 7,100,000 transactions per second on a standard gigabit network and 28.4 million transactions per second on a 40 gigabit network. The platform was founded back in 2017 by Anatoly Yakovenko. He has a wide range of experience with compression algorithms after his previous experience at Dropbox as a software engineer. Along with Eric Williams and Solana CTO Greg Fitzgerald, they created a new process of dealing with traditional throughput problems that existed in the Bitcoin and Ethereum blockchains. What type of consensus method does Solana use? As one of the most performant permissionless blockchain in the world, the network has 200 physically distinct nodes supporting a throughput of more than 50,000 transactions per second. When running along with GPUs, one of the biggest challenges with the distributed system is the agreement in time. Unlike Bitcoin, that uses proof of work algorithm as a decentralized clock for the system, Solana uses a proof of history method. With the proof of history, you are able to create historical records that prove that an event occurs during a specific moment in time. The algorithm is a high-frequency verifiable delay function. This function requires a specific number of sequential steps to evaluate. Transaction or events that are evaluated will be given a unique hash and a count that can be publicly and effectively verified. The count allows us to know when each transaction or event occurred, functioning like a cryptographic timestamp. Within every node, there is also a cryptographic clock that keeps track of the network's time and the ordering of events. This allows a high throughput and more efficiency within the Solana network. Let's have a look at the core innovations of Solana. Proof of history, a clock before consensus. Solana's proof of history consensus algorithm helps to create more efficiency and higher throughput rate within Solana's network. So by having historical records of events or transactions, it allows the system to more easily track transactions and keep track of the ordering of the events. Tower BFT, proof of history optimized version of PBFT, practical Byzantine fault toleration. Tower BFT is a PBFT-like consensus algorithm that is made to take advantage of the synchronized clock. The Tower BFT uses the POH as its cryptographic clock, which allows consensus to be reached without having to incur massive messaging overhead and transaction latency. Turbine, a block propagation protocol. The Turbine protocol makes it easier to transmit data to the blockchain nodes. Turbine is able to do this by breaking the data into smaller packets. This allows Solana to address issues of bandwidth and also increase its overall capacity to settle transactions faster. Gulfstream mempool-less transaction forwarding protocol. The Gulfstream protocol plays an important role in pushing transactions, catching and forwarding it to the edge of the network. This allows the validators to execute the transaction ahead of time, reducing confirmation time, faster leader switching, and reduce memory pressure on validators from unconfirmed transaction pools. So this protocol is what allows Solana to support 50,000 transactions per second. C-level parallel smart contracts runtime. C-level is a hyper-parallelized transaction processing engine that is used to scale horizontally across GPUs and SSDs. With this system in place, it allows Solana to obtain a more efficient runtime and allow transactions to run concurrently on the same state of blockchains. Pipeline, a transaction processing unit for validation of optimization. Pipeline is a process where a stream of input data is assigned to different hardwares responsible for it. So this mechanism allows transaction information to be quickly validated and replicated across all the nodes in the network. Cloudbreak, horizontally scaled accounts database. To achieve the necessary scalability of Solana network, it requires the use of Cloudbreak. Cloudbreak is a data structure that is optimal for concurrent reads and writes across the network. Archivers, distributed ledger storage. We use archivers for data storage. Data on Solana offloads from validators to a network of nodes known as archivers. These nodes can be lightweight, for example a laptop, and they will be subject to a check every so often to ensure they are storing the right data. Now, what is a Solana cluster? The Solana cluster plays an important role in Solana software. A cluster is a set of computers that are working together. They can be viewed from the outside as a singular system. Each Solana cluster is a set of independently owned computers that usually works together. They can also work against each other. The computers help to verify the output of untrusted user-submitted programs. Furthermore, we can use the cluster anytime a user hopes to preserve an immutable record of events or the programmatic interpretation of the events. Some use case of the technology is to track which computers did work that was meaningful in keeping the cluster running. Another way may be to track the possession of a real-world asset class. One good thing about this is that as long as someone has a copy of Ledger, the output of its program will always be able to reproduce and will be independent of the organization that issued it. Now let's talk about the SOL token. The SOL token is the native currency in Solana's ecosystem. So the token can pass to nodes within the Solana cluster in exchange for running on-chain programs or validating its output. Another use for SOL is to perform micropayments known as LAMP ports. The current circulating supply of SOL is 26 million and the maximum supply of SOL caps at 489 million SOL. SOL also has additional use cases. You can stake the token to earn additional rewards. So staking is a good way for users to earn profit if they're just looking to hodl their tokens. In conclusion, Solana solves the many traditional issues that earlier blockchain technology experiences. Solana displays a new structure for verifying transactions and a more efficient consensus algorithm. The platform will definitely be a strong competitor with Bitcoin and Ethereum. Solana displays the fast advancements in the crypto industry in just a decade. The platform will definitely be something to look out for as it continues to develop. Thank you for listening all the way to the end of this podcast. You can leave your feedback and questions by tweeting to me at my Twitter handle @SaturdaySatoshi, or you can leave a voice note at the link provided in the description. I will try my best to answer your questions and include them in the next episode, and your feedback is much appreciated. Remember, of all the things that I do, financial advice is not one of them. To get financial advice, contact your financial advisor. Let's meet next Saturday with another episode of Satoshi Saturdays. Signing out.